Start recording. Great. So, graphics in C++. Here we go. Create a new project. For now, hopefully my sound is working. It looks like it is. Great. For now, what you do in C++ is you make a project, and it's called an Sfml project. It's all set up for you to create some graphics, okay? If you get a build error, then go back and watch that video on how to set up Google Drive so that it actually I'm going to do that right now. Do I want to do that? No. Okay, here we go. Going to save it in there. Call it something, whatever, lab 12, lab 11, doesn't matter. Hit finish. If you build it and you get a weird error because you have a space in your thing, yeah, that's the error you get. You got to go and watch that video on how to set up code blocks to avoid that. I've also got a way to fix it. So I got it working. I run it. It should just draw a green circle on the screen. Okay. And it does have a console window as well, which you can see out stuff too, all that jazz. We'll talk about what all this code does. The first thing we need to talk about is the fact that C++ does not deal with graphics at all. There's no code built into C++ to deal with graphics or mouse control or keyboard control or joystick or anything like that. And the reason why C++ doesn't deal with any of that stuff or have any built-in code is because it's operating system specific. If I want to create a window, the code will be a lot different in Windows than it would be in Mac, than it would be in Linux. If I want to pull a computer for keyboard commands or mouse commands, all those commands will be different in Windows than they will be in Linux, than they will be in Mac, than they will be on the PlayStation 4 or whatever, right? So what someone has to do is they have to come and build their own library of code that will be able to tell what operating system you're running in, and then just create a whole bunch of functions to allow you to do that stuff without having to know how Windows actually makes a window, or how Windows checks keyboard presses, or how your PlayStation 5 checks for button presses, okay? So lots of people have made libraries. I think one of the best ones for C++ for 2D graphics is this one called Sfml. It stands for Simple Fast Multimedia Library. It was written by one guy, but there's a huge team behind it now. You could even write code and port it to Android and iOS. Okay? There's tutorials on this website that show you how to get started. There's also ways to look at time in the computer. It shows you how to get keyboard and mouse, opening windows, drawing things, designing your own entities, shapes, sprites, textures, sounds. All of that code is right here under. Here is all of the basically commands that you have access to. Okay? You can see there's rectangle shapes and circle shapes and mouse and music and keyboard and joystick. We're going to slowly learn them as we go along. So at first, this code has all been commented for the most part. And when you start an Sfml project, it includes the graphics file. And that's all we need for now. We're not making any sound. That'll also include keyboard commands and everything like that. Okay, this first line here basically creates a variable type called render window. In the past, we had int, we had float, we had string. Now, in Sfml, there's a type called render window. It'll write a little blurb about it too when you start typing in the type. Okay? It says a window that can serve as a target for 2D drawing. So if I type render window and then give it a name, what was the original name it called it? I think it called it window. Okay? Now, when I type the word window, I can actually write in brackets and fill in a little bit of information about the window. It wants like a video mode, a title, and some sort of style as well. I think in the past I just had video mode. I don't know what I did there. What was it? 800 by 600, yeah. 800, 600. that just tells it how big the screen's going to be, and then I give it a title like Sfml works. I think that was the first one I did because it took me a long time to get it to work. Okay, so that code is actually going to fire up a window that we can draw in. I don't need this line of code, window.setFrameRateLimit, but now that I have this window variable, there's a lot of things I could do with it. It's more than just a variable now. Like now it has, if I hit dot, like on string, I could hit dot length and it would show me how long the string is. These are called objects or classes instead of variables because they have a whole bunch of functions you can do to them, okay? So if I debug this thing, for instance, and go here, stop it and hit debug, I'll be able to see this window variable created in my watches. And it will have a lot more than just like a word associated with it or a letter associated with it. It'll have a whole bunch of options. Let's have a look. Hello? Hello? It's thinking. It's because I'm running from Google Drive just to practice here. If I was running from a USB, this would be a lot quicker, I believe. Okay, it's in debug mode right now. And if I go to look at variables, under watches, let me just click that one more time. Did I lose my watches? Oh, they're way over here. Look, I have a window variable and a shape variable. Okay. What they do, they actually, I can expand them and see all kinds of stuff about them. There's like all kinds of memory addresses here. There's also a size. I can see that it's 800 by 600. The debugger's not great for the compiler we're using. In Microsoft Visual Studio, it'd be a lot better, but that's cool. So we can make our own variable types that are more complicated than just int, string, float, and whatever, okay? Let's see what options we have available to this window variable. If I hit window dot, you can see the red ones I can't use, but the green ones I can. There's a clear, there's a close function, there's a create function, there's a display function, there's a draw function. There's a get view, get size, get settings, get position. What was the set frame rate limit one? Let's read that one and see what it says. All the green ones are ones we can use. Set icon, you can even make it an icon for it. You could set a joystick thing, set mouse, set position, set size, set title, set view, set frame rate limit, that's the one. If a limit is set, the window will use a small delay after each call to ensure that the current frame lasted long enough to match the frame rate limit. So if I type in the number 60 here, it'll try to flash this window 60 times a second on your screen. Okay, it won't be exact, but that's fine. Okay, so next line of code. I just want to draw a really simple shape. So there's a couple of different shapes we can draw to start. There's one called circle shape. That's a variable type. Okay, there is one called rectangle shape. Okay, that's another type of shape. There's a polygon too, I think, or convex shape, I believe it's called. Convex shape, yes, where you can draw something a little more complicated. Those are the basic shapes in Sfml. Okay, so I make my variable type, I give it a name, I call it shape. And then I could start looking to see what I want to do with the shape. By default, I think the shape has no radius. It's 0. So if I set radius, I can set how big it is in pixels. In this case, it's 100. Okay. I could make it 1,000. See what happens. There's a big circle. Okay. Made it a radius of 1,000. I'll keep it at 100. There's a bunch of token colors we can choose. If you just go color under set fill color and go color : : there's a bunch that you can pick. I'll show you later how to make any color with RGB values, but I could make this circle yellow. Okay. Now it should be a big yellow. Well, it's only 100 now. Yellow. Okay. What else can I do? There's lots of stuff I can do with this circle. I can actually move this circle, but I'm not going to move it yet because I want to talk about this code here. There's a while loop. This runs forever unless the window is shut or the keyboard key is pressed, the escape key. We'll talk about how to use keyboards later. But when I run this, if I press the escape key, it should close my program. It does. Okay. So it says here the main game loop exits if someone closes the window. Okay. If I get rid of this line, window is open, closing my window won't close my program. Watch. Remember, a computer's kind of like a baby. It needs to be told exactly what to do. Look. Oh, it did work. What the heck? It shouldn't kill my program. Hold on. Let me save. Oh, okay. It does work. Interesting. I didn't think that would. Oh, you know what? It's right here. It's right here that it checks. Don't worry about this loop for now, guys. This is an event loop. This little code here, this will be later for keyboard and mouse presses and things like that. We'll start talking about that a little more. If I get rid of this window.close line, that makes my program not close. Whoa. Oh, I see. It's got an if statement with nothing in it. So we'll just comment that out. Theoretically, it won't let me close my window. It'll just keep it open forever. Let's look. Go.
So why did it do that?
It's because this line is gone. It says if there is an event where someone closed that window, then actually physically close it. You have to tell it to physically close the window. We'll talk more in later labs about this block of code here. We won't even look at it for now. We could actually just delete it and it would be fine. The only thing it's doing is checking for the event that someone closes the window. Okay?
How are you just writing event there and it's not giving you an error? Like in the beginning you just wrote event. How is it not giving you an error?
Okay, event is the variable type. Okay? It's built into Sfml, and the little event is the name of the variable, so you could have called it whatever you wanted. Okay? I just called it little event. It's probably not great coding to do that.
But how come it's not highlighted or something to show that it's part of Sfml?
Yeah, it doesn't do that. It only does that with C++ code, because this compiler doesn't know anything about Sfml, right? So it will auto-type the Sfml stuff, but it's not going to color it. That would be nice if it did. I'm sure you could make it do that, but we're not going to do that. So I could delete all this code and my program would still work fine. It just needs the 3 lines. Window.clear, which erases everything. Window.draw, which draws your shapes or your sprites or anything like that. Let's see what happens here. It'll run fine. It won't be able to close the window, but I could still close my console and it'll close everything. Okay? It doesn't even let me like move it because there's no events happening. It's not pulling any thing, but it does let me run. I'm going to keep those lines in because it actually, this event loop allows me to move my window around and maximize and minimize and all that kind of stuff. Okay? There we go. Oopsie. Just for the sake of argument, let's write a cout statement in here and see how often this thing counts. How often this little loop runs, right? Theoretically, it's trying to run 60 times a second. Let's write a cout hello and see if it'll print it out around 60 times a second. It'd be hard to kind of make that out, but see how it's printing hello there on my console?
That's 60 times a second?
Well, let's check it out. I'll make a number like int count or something like that, right? I'll set it equal to 0. I'll print it out, and then I'll make it go up by 1. Ugh, count is already a word in C++, so I'll do count 1, I guess. Count 1 plus plus. Okay. Let's try to count it off here. I'll run the program for 5 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. About 300, right? 5 seconds. That's about 60 a second, give or take, right? So we could see that that's running 60 times a second. What if I kill this line here? Let's see how fast it can truly run. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. It ran significantly faster, probably about 600 frames a second, maybe a little more, maybe a little less than 600 frames a second. Okay, so the computer can draw a single shape very, very quickly. I'm just going to leave the frame rate in there at 60 because these monitors all refresh 60 times a second, so that should be good enough. Okay. So what I want to do is just look at how to draw things in Sfml. If you notice these 3 lines, there's always a clear the screen, then there's a draw command, and then there's a window.display. It explains it a little bit. It says this line clears the screen. Okay, we want to clear the screen 60 times a second or else everything will kind of smear across, right? Let's check and see if that's the case. There is a move command for shapes. For circle shapes. So I'm going to go shape dot, and then I'm going to look for move. I can see there's 2 options for move. One is it's looking for this vector 2f thing. We'll talk about that later. It's a 2-dimensional number. The other is it's looking for an x value and a y value. They're just floats. So I'm going to write 5 for my x, 0 for my y. And this thing should move across the screen 5 pixels every frame. Hopefully. Go for it. Okay? And it does. It moves at 5 across, so that's great. What happens if I get rid of the window clear? Do you think it should smear it across the screen because it's not erasing? Yeah, look at that. It looks awful, doesn't it? Okay? Not only is it smearing, but it's vibrating too. Okay? What happens if I get rid of the window.display command? It's just a white screen, okay? So, here's the deal with it. You want to clear the screen, obviously, or smear across. You also want to draw all your shapes after that, but you don't want to draw them on the screen as the message comes to the computer. If you do that, everything will get drawn not in sync. They'll all get drawn at different times whenever the computer sees that draw message. If I have like 50 draw commands inside of here, they will all be drawn whenever the computer receives that message. And that will start making the screen flash and doing weird things. So what you actually do is you draw everything to a video card, like some sort of buffer, some sort of memory spot in a video card. But you don't put it on the monitor until you get to this command. So once the computer decides everything that's going to go on the monitor in that 1/60th of a second, then the display comes and says, okay, shoot it all to the monitor at once. So that's why there's 3 lines of code here. First one to clear it, second one to draw all the pictures in memory, and then the last one is to put everything on the screen. Displays everything on the video card to the monitor. So that's the 3 draw commands the 3 window commands we'll need to draw stuff. We could draw more than one shape if we want. Let's maybe practice doing that right now. Okay, so there's my yellow circle. It's moving across the screen. Perhaps now I'll make a rectangle shape. So I'll go up here somewhere outside of my for loop, right? I don't want to make variables inside of a loop running 60 times a second. Maybe I'll call this shape 2. Okay? Now, shape 2, if I want to draw it, it's a rectangle shape. I have to put in a command to do that. Window.draw shape 2. Oops. Shape 2, like that. And I'll run it, and I won't see anything. The reason is, by default, whenever it draws a shape, it draws it with no size. Okay? So I gotta find a way to set the size of my shape 2. So somewhere here, maybe I'll write shape 2 and hit dot and see all the commands I can do. Is there a set size command? Yes, there is, right here. Set size, okay. It looks like it takes in this thing called a vector 2f. So I'm just going to write vector 2f. It means a two-dimensional number. That's a float. And in brackets, I'll write the size I want. I'm going to go 100 pixels by 100 pixels, like that. I wish it would let you just write 100, 100. I might overwrite that later in the code so that set size can just take in two numbers. I don't really like the way that's set up, but that's a tomorrow problem, I guess. Okay, let me see. I didn't set a color. What's the default color?
Black.
White. Yeah. Okay, that's 100 by 100 apparently. Okay. So if I want to set a color, I can do that the same way I set a color on my circle. I'll leave it white for now. Maybe I'll move that one down. Shape dot move, and then maybe 0, 5 in the Y direction. So it'll move. Down is up and up is down, and in Sfml, by the way. Okay.
How does it know if it's moving the circle or the square?
Oh, shape 2. Shape 2 is the square, right? So that's why that didn't move. It actually moved the circle down 5 and over 5. Okay, so there you go. They're both moving together now. You could start getting interactive with it too. You can bounce the ball because, you know, every object has an X position and a Y position. Let's practice bouncing this ball, maybe. Okay, so first thing I'm going to do is just output its X position. So my variable is called shape, right? That's the circle one. I'll hit dot, and there'll be a get position command here. Get position right there. Great. It will not let me output this on the screen. I'll show you why. Crazy error. 500 line error. One of the gripes about C++ is the errors are often very confusing and cryptic. This one included. Basically what it's saying is I don't know how to output this get position variable because it's not a float, a string, or an int. And that's what C++ knows how to put on the screen. So if I go to get position, I can see if it's a string, a float, or an integer. It's not. It's this thing called vector 2f. Okay? And vector 2f always has an x and a y number associated with it. So if I hit dot on this, you can see there's an x and a y variable that will that is incorporated in that get position. So I can actually print out .x if I want. It just doesn't know how to print out 2D numbers. You could actually go into the code and overwrite it to get it to print it out if you wanted. But oh, I'm c-outing too many things here. I'm c-outing my frames and something else, right? This count thing. Set frame rate limit to 60. Great. So yes, now I'll output the X position. I'm going to try to stop this program once the X position hits the edge of the thing. Oh, I got to be a little quicker than that. So once the ball hits the side, I'm going to stop it. Bam. Oh, I closed my console too. Hold on. I don't want to close my console. It's around 600. That's where it hit the edge. Okay. So in here, I could just say if, using a trusty old if statement, if get position dot x is ever greater than 600, bounce that ball back the other way. Okay. How am I going to do that? Well, this number should be -5 if it's ever bouncing. But I'm kind of in a pickle here because I need this to run. If I just put shape.move in here -5, what's going to happen is this is going to run 5, every frame, and this is going to run -5 every frame, and the ball's just going to stop, right? So I want to avoid that issue.
Definitely.
Not here today.
What if they're not equal?
So it should stop, bam. Okay, but I actually want it to bounce. So the way around that is to make this number a variable. I'm going to just make it a float variable. I'll pick somewhere in here and write float x step. I'll let it equal 5. Okay. I know that this code is going to be running every time through my loop, so I know the ball is going to be moving 5 pixels every time. Okay. And in here, I don't put a move command. I just make x step equal -5. It's kind of like a switch that gets turned on to say to your ball, hit the edge of the screen, then bounce the other way.
So what did you set X step as? Was it an int?
I set it as a float. Everything in Sfml is a float. Okay? And there, it hits and now it's going -5. I don't have an if statement in there that tells it if it goes to the left side to bounce back, but I can easily enough do that, right?
Yeah.
So that's how we're going to kind of like Sfml, the graphics library, all that stuff is a lot of new code. But most of the stuff, once we know how to draw shapes and set shapes positions, most of it's just going to be like if statements, for loops, stuff like that. All the old code we've known, right? We're just going to have to be a little more clever about how we code, because now our code's running 60 times a second. And we're not used to having this code constantly running in some sort of loop. Okay? So work through lab 11 and 12, and we'll go over some more topics tomorrow. Okay? Try to get that ball bouncing around the screen if you can. Up, down, sideways, left, whatever.